If you walked into our home at a very special time of the day called bedtime, you would be greeted by a ritual we call putting the little one down to bed. Putting the kid down to sleep is apparently a very difficult thing that I didn't know was such a thing until I became a parent. So here's how it works. We go upstairs, we give the little guy a bath. Our little one's about 2 years old now. And then we walk him to his room, my wife and I. Then we do the bedtime routine, which is putting on the jammies, changing the diaper, singing the song, reading a few books, reading another book, and then rocking him in the rocking chair. And then just when he's right about to doze off, you kind of lift him up a little bit and just drop him really gently into the crib. And you just hope for the best, right? And he's kind of dozing a little bit, and you kind of back away, and you close the door really lightly. Just don't make a noise. And the like doorknob clicks, and then suddenly you have this like ear-piercing scream, a horrifying feeling, and a lot of yelling and crying because children don't like to sleep, and they don't want to sleep. And so, as it turns out, that this became our story for a very long time, ever since really the little guy was born. We'd sit in the living room for a long time, maybe like sometimes it'd be half an hour, sometimes it'd be an hour, sometimes multiple hours, just kind of watching this drama unfold. And we just wonder, like, oh my God, like when is he gonna actually go down to sleep, you know? And don't let the cuteness fool you. If I turned on the volume, it would be horrifying. Okay, so then we're sitting here going out of our minds, just like, when is he gonna like conk out? When is he gonna get so tired he just can't scream anymore? Well, this is actually backed by a very serious, a little bit of a somber background, because when our little one arrived, I actually entered into a pretty kind of a dark period in my life. I was going through a lot of postpartum paternal depression because life had changed all of a sudden. There were some health complications that added extra stress, and my life was kind of flipped upside down, and I didn't really know how to deal with it. There was a lot of feelings of helplessness, like, hey, I can't do anything to help my kid. There was frustration because I didn't know how to do this parenting thing, and I was all brand new at it. I was really angry because I felt stuck. I was angry at my situation. I was angry at anything that I could place blame on that wasn't myself. I put it out there. And then finally, I felt a lot of despair. I felt really hopeless. I didn't know if things would change, and I didn't know if this would be my lot in life for the rest of my life, which, when you talk to other parents, the answer is, yeah, it is. And so when a lot of this crying kept coming, and it kept happening and kept happening, it stirred up a lot of these old feelings of like, oh my God, things will never change. So obviously, best counsel is to go seek out help and advice, to seek out community and relationship, which I did. Friends reached out to help. I sought out a therapist and a counselor who was able to help me. But I also realized, because my training is in software engineering, I know that there are other places where I might be able to help out and find the own solutions to my problems. I don't just need help, I need data, okay? And I need lots of data. Just imagine time series data, time series data that just basically tells me everything going on in the room. Temperature, humidity, environmental sort of things. What I want to know is like if there's correlations between the time of day versus, you know, whatever, like the weather, you know. There's probably some insights hidden in data, right? Probably. So I set out to find out. And how do you find out? Well, I built a little machine. It's really just a Raspberry Pi with some sort of sensor devices attached on it. So I built a Raspberry Pi. There's a USB microphone on it. There's a ambient environmental sensor that measures temperature and humidity also attached to it. And this Raspberry Pi sits in my kid's room. And it just pushes out different updates up to a time series database sitting on the cloud. So let's kind of dive in a little bit. I'm going to walk you through how the hardware device works. It's simply a device that sends up 10-second clips, recordings in the room, and it sends it up every 10 seconds, or every minute it records a 10-second clip. And then here we use aRecord, which is a Unix utility to measure these, to record data. And then we'll use a tool called SOX to pull out audio information about the clip. Over here, we're simply looking for loudness. And then when you go plot it on a graph, it looks something like this. So the yellow bar is kind of the peak, like the peak volume recorded during the sample. The red bar is the trough, like the minimum, or like the lower end of the volume. And then the middle is kind of like the mean of loudness in the clip. So if I asked you to look at this graph, do you know when the kid was crying? Like, what would your best guess be? It's probably those two spikes in the middle with the yellow line. Maybe this one, the 6 a.m. one as well. And then maybe by 8 o'clock we got him out of bed, which is why everything like jumped up. So this was actually V1 of my device. V1 of my device was simply record the ambient noise level in the room, and basically if it spikes above an arbitrary threshold, which I defined somewhere around here, then he must be crying. And as it turns out, it's actually not very accurate, because if you're like in the other room and you accidentally drop something on the floor, like that'll cause this to spike and cause an incorrect reading. So I took this as my opportunity to get into deep learning and neural networks, because I had kind of gone over that stuff in school, but that was maybe a decade ago, and really the state of the art had advanced a lot by the time I was beginning to work on this project, which was a couple years ago. Right around the time, a lot of new tools were coming out. TensorFlow, PyTorch are among one of many that kind of came out. And so I decided to take a look at TensorFlow. And lo and behold, in the TensorFlow docs, there is a sample application that does audio recognition. So I thought, hey, this is perfect. They built the stuff for me. I'm just going to plug in my data, and I'll be good to go. By the way, if you actually try to look this up, this web page doesn't exist right now because they just released TensorFlow 2.0, and they're rewriting many of the documentation. So I wouldn't be surprised if this came back on, but for now, bear with me. I'm going to be talking through a lot of things that you won't find online yet, but this application does live still in the TensorFlow source code. So if you're going to GitHub, go to the TensorFlow project, you're going to find this. We're going to go at a bit of a high level, but the core concepts around a convolutional network. A convolutional neural network is basically an architecture of a neural network that is really good at detecting things like image classification. And the key to the power of this network is the operation called a convolution. The convolution over here, we're taking a two-dimensional convolution, and essentially the network is trained on a subset or like a little sample of the image, and we slide that little window over throughout the core of the image in order to get smaller subsets. And what that means is that the network is actually trained to detect features that we call translation invariant, which basically means like a feature can exist in one part of the image, but can also exist on another part of the image. And so that makes it very easy to generalize detection of features through different types of images. It basically makes it very flexible. And over here, you can kind of see, this is a slide pulled from a very popular lecture. This is what the network is quote unquote seeing. We're actually visualizing what the filters at every level of the network is seeing. And as you can see, as the network gets deeper, these features become more generalizable. They're kind of pixelated on the left side. And that's not actually a bad thing. That's actually a really powerful insight. And those are like the key features that allow the network to detect what it detects. Now, the key insight in moving from image to audio is that audio is basically, we can turn audio files into images. Who here's maybe played an audio file in, like, remember Windows Media Player or like Winamp, and you turn on the visualization? Do you remember how trippy that looked? So this is very similar to that. What we're seeing here is a mapping of the frequency domain on the x-axis and the time domain on the y-axis. So let's take the word yes, for example. By the way, these two audio samples are taken from the Google Speech Commands open database. There's like 65,000 or more audio samples that they use to train their audio recognition data sets on. And there's a bunch of like Kaggle competitions for these things too. But let's see the word yes. Yes starts in the low register, yeah, and it ends in the high register, s. That's the sound of the S passing through your tongue. So as you can see, all the energy is mainly in the low frequency, and then it moves into the high frequencies. And that's how your network's going to detect the word yes. And the word Sheila is actually the opposite. Sheila begins in the high registers and moves to the low. She, And just for fun, this is what my son sounds like. One thing that we should also point out is that I noticed there was a link to a paper that was published by some Google researchers, and they call it CNNs for small footprint keyword spotting. And I thought small footprint keyword spotting, this is probably some of the research that backs a lot of the device, like the wake words we have on a lot of our smart home devices or on our cell phones. And in this paper, they actually propose an architecture called CNN Trad FPOL3. And if you, like I, don't know what that means, that's totally fine. I'm not going to try to explain it. But as you can see, we can actually visualize the architectures of these things. Essentially, this architecture has two stages of convolutions. The convolutions are then added on with a ReLU activation function, and then we use a thing called pooling, which basically simplifies or downsamples the architecture, or like the total number of nodes in the network. And this ends up being an architecture that works well for devices that have to run on like batteries or have limited processing power. All right, let's actually get into the practical aspects of deploying this thing onto my Raspberry Pi on my son's room. So the ML pipeline usually consists of gathering data, cleaning it up, and then training a model on top of that. And then, yeah, there's a lot of very specific things about this pipeline that I'm going to gloss over, but you're going to get the general gist of it. So the first thing we usually do is we're going to record data. We're basically going to generate our sample data set. So luckily for me, I have a captive audience, and I'm recording these clips, and I'm continuously sending them up to a bucket in the cloud. And then we need to actually align the data frames so that every sample that I'm sending to my model can be the same width and the same normalized volume. And the way I'm going to do that is I'm going to use some utilities to basically smash all my samples together, and then I'm going to divide them up again to chop them up at the correct intervals. Over here it's 10 seconds. And then I'm going to resample them at the right sampling frequency, 22 kilohertz. And then I'm going to normalize the volume a little bit. I'm going to bump up the volume to by about 45 decibels. And then comes the hard part. We actually have to do a bunch of labeling. And labeling is one of the most important and also one of the most just time-intensive, kind of back-breaking work that you have to do to get a large data set. So I'm using a tool here called EchoML. EchoML is an open source web app, basically, that you can deploy. And it basically reads a bunch of data in Microsoft Azure storage buckets. It's kind of like an S3. And basically, you store your audio files there, and then you can actually pull up every data file that you need to label and actually attach labels to them. So over here, I'm labeling this particular file as a crying sample. And then you take all those data sets, you take your labels, and then you grab the corresponding files that have been labeled, and then you drop them into a file structure that the TensorFlow example defines for you. So I've got a bunch of files that I've labeled as crying. I came up with another data set called whining, because that's what it sounded like to me. And then there's a few other, if you wanted to, you could add some other files or to some other folders if you were interested in some other labels as well. Also, having extra data will actually allow your model to become more accurate, because it's going to know how to differentiate between one sample and the other sample. So having negative examples, basically, is actually a good thing for your model. Next up, you basically run the Python training script. So the TensorFlow example actually already builds in a lot of the things you have to think about. It's you specify the sample rate and the duration of your audio files, and then you basically say which labels you're looking for. And then you're going to run. You're going to run the script, and over here, this is running on my MacBook. I ran it for a couple of hours, maybe more. And over here, you can specify how long you want to train it for. When you're done training, it's going to spit back some stats about the accuracy will come out. It's a little bit difficult to see here, but on this next slide over here, Tensor Boards is a utility that lets you visualize the accuracy of your model. And over here, this is actually a pretty good run, but there will be cases in which you're going to visualize like a low accuracy. Perhaps your model will converge on a number that's lower than it should be, or maybe the cross-entropy function, which is a measure for how quickly your model is converging, is actually wildly bouncing around and stuff like that. I won't go into it here, but you can learn about how you can tweak the parameters of your training to make this look really optimal. Basically, you're going to make a decision at the end of this to see whether your model is sufficient to continue. And let's say, for the sake of time, that I've achieved a decent training run with reasonably good accuracy results. What I'm going to do is I'm going to now freeze the model. Basically, this command serializes the TensorFlow graph into a protobuf binary called graph.pb. And then I'm going to ship it. I'm going to basically send that onto the device. Now, on the device, what I can then do is I can record a sample, and then I can basically run the labeling script, which basically executes the Python script on top of any input that I give it. And out comes an ordered list of labels and their probabilities. Over here, you can see that the crying label has a high confidence interval. The probability of it being crying is 95%, which I trust it. So, will it work? At this point in time, I spent a lot of time just working on raw data, and a lot was at stake. So the night I was going to deploy this, we did the bedtime routine, we put on the jammies, we sang the song, we rocked the little guy, we put him down into his crib, closed the door, and right on time, right on schedule, he started wailing. And I ran back to my computer, and yes, real time, up to the minute, streaming data of the little guy's crying. Over here, he had a bad nap, and he's not having a good evening either. It was bad. It's bad. And seeing this data, unsurprisingly, made me feel worse. And I actually tried to slice the data. I tried to look for some sort of indicator, some environmental indicator as to whether there was a high correlation with the time of the day or the day of the week or the temperature and the humidity or both. And really nothing jumped out at me. There was literally there was actually a minor correlation with the day of the week, which might actually indicate some sort of correlation with our bedtime routine, but it was like so low to be nothing. So here we are again in the living room watching the baby monitor and just wondering, like, when will this end? Like, am I doing something wrong? I put a lot of work into this and like it doesn't seem like anything's working. Like, what am I doing wrong? And later that night, my wife and I are talking, and he's still wailing. He's having a bad night, and she just looks up at me and says, like, I'm gonna go in the room. And then to which I said, no, you can't do that. If you go in the room, he's gonna learn that it's okay to cry, and we're gonna reinforce that it's okay to cry because mom's gonna come in the room or dad's gonna come in the room. But she was like, no, we have to go in, like, trust me. So she tiptoes upstairs, opens the door, it's crazy in there, and then she closes the door and it's quiet, it's silent. And a minute passes, 5 minutes, I don't hear anything except the white noise machine. And then finally at the 20-minute mark, she comes back out, closes the door really quietly, and then tiptoes down the stairs. And I say to her, what happened? What did you do? And all she could say to me was, kids are weird. I calmed him down, and then I put him back in the crib, and I just sat down on the floor. And I looked at him, and he looked at me. And we just kept looking at each other. And then she said, I then grabbed the blanket and lay down on the floor, and he did the same thing too. And soon enough, he was asleep. And I thought to myself, like, it was that easy. It was that easy. How did I miss that my son just needed to be comforted? How could I have missed, or why was I so against the fact that he was just seeking some reassurance or comfort? And this was clearly not built into my model. And isn't it true that this is how we operate sometimes at work? Sometimes we have all these systems and models and metrics and funnels and OKRs, all these things that are great to drive levers of performance in the business, but there are real people interacting with or working with our systems. And if their inputs aren't brought into the process of developing these models, we're going to lose a key part of integrating them with the business. And as we know, when we lose track of the humans that are in the show, it's ultimately bad for the business. You can tell your boss that. I mean, I'm pretty sure your boss would know. We aren't able to connect with the people that are building the systems, who may have questions about how it's built, the people that are reading the outputs that come out, are reading reports that are coming out, who defines the metrics that we're looking for. And finally, the people that are perhaps being influenced by the things that we do with our systems and our models. If our models are optimizing for a certain outcome, how do people feel if they're being squeezed by it? How do people feel about being on a marketplace where perhaps they have an opportunity to work or earn a living and things are changed on them? How will their input be incorporated into your model? So as more and more data comes in, as we live in an increasingly automated world, as you and I at work are building and deploying models to increase efficiencies, we have to remember to incorporate and re-emphasize the human experience so that they're built into the loops that we use to build our systems. And how do we do that? Well, I have what I felt was a silly idea, and I think it's actually a pretty good idea, but it does feel really silly. And I'll just say it here. We have people in our field whose job is to connect with people and to understand them. You may have a UX researcher that you work with. You may be an anthropologist. I've had the pleasure of working with anthropologists on projects where they've literally embedded themselves with the family for a week to figure out how they use the product. Or if you're perhaps a founding team, you're a co-founder of a company, or you're early stages, you may actually be interviewing customers as dictated by the lean startup methodology. You may be talking to your customers face to face. How can we bring that kind of idea and that mindset into building machine learning models? And here's my silly idea. My silly idea is to bring in and to bring to the forefront things called personas. How many of y'all have heard of personas before? Great, love it. So in the field of user-centered design, this is becoming more and more popular. We actually have product teams develop these images or these categories of people, these types of people that they're building the product for. These could be stakeholders that are internal, like Reeve over there, or they could actually be customers like Jenna and Lydia. And these personas are assembled from reports from the field, from actual research, from people studying customer segments. And they're not exact people, they're not real, they're composite, but they actually help us think about how to think about the people that we serve. So what if you build personas and you put them up on the walls? What if you, with your data science team, remember that every time you deployed a model, that you had to remember what you were doing for Jenna, or for Lydia, or for Reeve? We need human-centered design at every stage of the ML pipeline. And it starts with you, it starts with us. So let's start by connecting with people first. So even when we overly focus on data, we risk being out of touch with the needs of the people that we're supposed to serve, right? So what I'm encouraging us to do is that we talk to people and we keep them first and foremost top of mind. It's the right thing to do for the business, but more so it's the right thing to do to another person. So thank you very much. You can find the source code. Hopefully I've showed you it's easy to build an audio recognition model, and hopefully I've shown you and inspired you to think about personas as you're building things. Thanks.